A silent traveler races through the solar system, darker and heavier than anything its size should be. To the naked eye, it looks like nothing more than a speck of light. But to the instruments trained on it, the signals are growing stranger by the day. This is 3 Atlas, only the third confirmed interstellar object in human history. At first, it seemed to be just another comet. Unusual, yes, but still explainable. Then came the anomalies. A thermal pulse beating like a clock from deep inside. A radio burst repeating across continents. A sudden flare 40% brighter in less than an hour. And finally, the unthinkable. The models predicting its orbit began to fracture. Its path bent closer toward Mars. Now astronomers face a possibility they have never confronted before. 3 Atlas may not survive its passage. The stresses building inside it, chemical, mechanical, or something else entirely, could tear it apart in a violent explosion. If that happens, the fragments will not simply drift harmlessly into the void. They will surge outward in a storm of dust, plasma, and high-energy particles. Shock waves rippling down the line of the solar wind. Mars is directly in the path, but Earth may not be beyond reach. The clock is ticking, the evidence is mounting, and the question grows harder to avoid. Are we watching a comet or the countdown to a detonation on a scale we have never seen? Explosions in space are not unfamiliar to astronomers. Stars collapse. Supernova release more energy in seconds than the sun will emit in its lifetime. And smaller bodies like comets and asteroids have been observed to break apart before. Shoemaker-Levy 9 fragmented under Jupiter's gravity in 1992. Its pieces colliding with the planet 2 years later in a series of spectacular impacts that scarred its atmosphere. Comet 17P Holmes surprised the world in 2007 when it suddenly brightened by a factor of 1,000,000 in less than 48 hours, ejecting a vast shell of dust. These events were powerful, but not unprecedented. With 3 Atlas, however, the context is different. This is not a local comet, a leftover from the formation of our own solar system. It comes from somewhere else entirely, carrying chemical signatures and structural properties no one has ever seen before. The risks are not just scientific unknowns. They are existential questions. What makes astronomers nervous is not just the possibility of fragmentation, but the scale. Estimates put the mass of 3 Atlas at over 33 billion tons, far too large for a normal comet. If such an object were to rupture, the debris cloud would dwarf anything in recorded history. High-velocity fragments would scatter across millions of kilometers, each piece potentially large enough to carve craters or disrupt orbits. The dust and plasma release could create electromagnetic storms as they interact with the solar wind, disrupting communications, satellites, and possibly even power grids on Earth. While space is vast and shock waves dissipate quickly, the interconnectedness of the solar system means that no event on this scale happens in isolation. The chemistry of 3 Atlas deepens the puzzle. Unlike typical comets dominated by water, ice, and carbon monoxide, this object is rich in carbon dioxide, 8 times more than water by some measurements. Such a composition is unknown among comets studied in the solar system. Carbon dioxide ice sublimates rapidly under sunlight, and if layered within the object, it could create pressure pockets. As heat penetrates, these pockets may burst explosively like buried bombs triggered one by one. The heartbeat pulses detected every 4 hours could be the signature of these cycles, building and releasing pressure in regular intervals. If multiple chambers rupture at once, the entire nucleus could fail catastrophically. The thermal and radio anomalies add to the unease like fuel to a fire already burning. Both Hubble and the James Webb Space Telescope have now confirmed what no one expected to see. Periodic flashes of heat, a pattern as if the body were warming and cooling in cycles far too regular to be explained away as random outgassing. A comet is supposed to behave chaotically. Jets firing from fractured surfaces when sunlight strikes volatile ices. But 3I Atlas does not act like a snowball venting steam. It pulses, its energy building and releasing with a rhythm. Instruments in orbit and on the ground have synchronized to the same unsettling beat, a heartbeat echoing across millions of kilometers. At the same time, The world's most sensitive radio arrays, from China's FAST telescope to Europe's LoRa network, have logged bursts of narrowband emissions that align almost perfectly with those thermal peaks. Radio noise is common in space. Quasars blaze, pulsars tick, the sun itself crackles. But those are broad and wild, chaotic across the spectrum. What Atlas produces is narrow, precise, and coincident. The alignment across wavelengths is what unnerves researchers. Heat and radio, two different channels of physics locked together in repeating intervals. Nature is clever, but not often so coordinated. Skeptics argue for exotic chemistry. Perhaps carbon dioxide dominant in 3I Atlas is undergoing a kind of phase transition deep beneath the crust. Its expansion and contraction timed by the sun's steady radiation. Some theorize about crystalline ice leases expanding and collapsing like giant lungs. Others suggest resonance, layers of ice and dust acting like a bell, ringing in harmony with thermal stresses. All of these explanations remain possible, but none sit comfortably. None explain the sharpness of the radio bursts, the clockwork precision of the cycles, or the persistence across months of observation. And so the speculation shifts. If such regularity is not accidental, then what is it? Could this be the functioning of systems hidden beneath the surface, relic machinery, or even the operational components of something more deliberate? For decades, SETI researchers dreamed of narrowband signals as the hallmark of intelligence. What they expected to find was a beacon sweeping across the stars. What they did not expect to find was a comet-like body broadcasting its pulse in rhythm with its own thermal fluctuations. Mars now finds itself at the very center of this debate. By sheer coincidence, or by something more, 3 Atlas is on course to pass alarmingly close to the red planet. Orbital models predict a near approach within a few million kilometers close enough that if the object disintegrates near perihelion, Mars will be directly in the line of fire. Its atmosphere, thin as a wisp compared to Earth's, offers little protection. Even modest fragments could slam into its surface, carving craters and ejecting dust high into the skies. A major shower could,